Hello, we're moving into week 4 now. This week, we will discuss several study designs in epidemiology and will highlight some important elements that epidemiological studies have. We will start with a general overview of the most frequently used study designs in epidemiology, but in this lecture, we will focus on the most basic observational epidemiological studies, case studies and case series, cross-sectional studies, and ecological studies. Epidemiological research encompasses several types of study designs. Each of them represents a different way of harvesting information on certain characteristics: the use of a reference group, experimentation, the unit of observation, the temporal sequence of the study, and whether the selection of the design is based on exposure or disease status. Let's take a closer look at these elements. A reference group helps as a point of comparison to judge the effects of an exposure. As we will see, epidemiological studies might or might not have reference groups. Another element is whether the exposure has been manipulated or not. For example, if we want to know whether exposure to vitamin C prevents colds, we can manipulate the exposure and assign a group to receive vitamin C and compare cold rates with a reference group that received a placebo. Or we can just classify people into those who have taken vitamin C and those who did not. In the first case, we are conducting an experiment, and in the second case, we are only observing the effect of vitamin C. The unit of observation indicates if the data is individual or aggregated. For example, we can classify individuals in smokers or non-smokers and compare rates of lung cancer in the two groups. Or we can collect aggregate data of smoking by regions and compare lung cancer rates according to the regional smoking rates. Epidemiological studies also depend on the direction in which exposure and outcome data is collected. For example, you can obtain a snapshot of the exercise habits of a group and compare this with the prevalence of diabetes. Or you can conduct a longitudinal evaluation and track over time the incidence of diabetes in groups of exercisers versus non-exercisers. In a prospective study, you start with cohorts of individuals and look forward over time until the event occurs. Individuals are defined according to their exposure status and then they are followed over time. In retrospective studies, you look back in time to study events that have already occurred. The cross-sectional is a snapshot in time, so the study exists on a single point in time. Study selection can rely on how do we use the exposure and disease status information. We can use the exposure information to create groups and then assess and compare the incidence of events or outcomes in the exposed and non-exposed groups. On the other hand, we can create the comparison groups by disease status and assess and compare their past exposures. There are many different taxonomies to classify study designs. First of all, we can divide them in descriptive or analytic, depending on their purpose. Descriptive studies examine the frequency to which diseases or events occur. Analytic studies evaluate the relationship between exposure and outcome. The hallmark feature of analytical studies is the use of an appropriate comparison group to obtain this information. We can also classify studies based on how they handle the exposure in experimental and observational studies. In this classification, experimental designs include the randomized controlled trial, and observational designs would include case control studies, cohort studies, cross-sectional, and ecological studies. Researchers such as David Sackett and others in evidence-based medicine have created hierarchies of evidence based upon study designs. In the web base, we have editorials and expert opinions, which do not constitute study designs, but are the largest type of evidence available. At the end, everybody has an opinion, right? And then we go up from case reports to systematic reviews. Some have debated this pyramid of evidence as a simplification of the value of evidence for many other different questions in epidemiology, and because it excludes other types of studies such as qualitative research. This is open to debate, but we're not going to try to solve that discussion here. Let's take a closer look to case reports, case series, cross-sectional studies, and ecological studies now. A case report is a detailed presentation of a single case, usually of some event or disease that has not been clinically described in the past. Case reports are in many ways sentinel events which can lead to testable hypotheses later. You might have heard about Dr. Oliver Sacks. He was a famous neurologist who died last year and who explained neurology in a way that captivated a wide audience of scientists and non-scientists by focusing on individual case reports. One of his latest case reports published in Lancet was called by him The Strange Case of the Woman Haunted by Dragons, and it was a case of prosopmetamorphosia and facial hallucinations. With these case reports, Dr. Sachs created in his books and essays moving portraits of the human beings behind often bizarre neurological and infrequent conditions. Case series are an important interface between clinical medicine and epidemiology. They provide information about the experience of groups of patients with a similar diagnosis. Cases might be identified from a single or multiple sources, and generally they report on new or unique conditions. It might be the only realistic design for rare disorders, and this is the most common type of studies published in medical journals, with about one-third of all. In 1981, the CDC published one of the morbidity and mortality weekly reports describing cases of a rare lung infection called pneumocystis carinii pneumonia in 5 young, previously healthy gay men in Los Angeles. All the men have other unusual infections as well, indicating that their immune system was not working well. After the Associated Press and the San Francisco Chronicle and the New York Times covered the story, doctors from all across the US flood the CDC with reports of similar cases, and thus the AIDS epidemic had officially begun. Case series are very useful for hypothesis generation and to inform very rare diseases. However, they cannot assess disease frequency or test cause-effect relationships in the absence of a comparison group. There are a few instruments to assess the quality of case series studies, and I wanted to bring you this tool today for your reference. It was developed by the National Heart, Lung, and Blood Institute in the US to assess case series studies. And with this, we're going to finish the first part of this lecture, and then we will continue with a review of the cross-sectional and ecological designs.